Hello guys and gals, and welcome to a new tutorial. In today's video we're going to be covering this really cool effect where our material will keep track of our player location and will update this nice little effect on the floor based on where we're running. And you can see if we jump, it will recognize that we're jumping and will shrink our area. Yay! Pretty cool. So before we begin the tutorial, I just want to say thank you to everybody that's already gone over to Twitch and followed me there. We reached affiliate in less than a week. We have over 100 followers there and we've got a few subscribers, but I do need more support over there. The more support I can get there, the more that both of my channels are going to grow. Obviously, if you have Amazon Prime, it is free to subscribe to me over there. And I really would appreciate the support. Now that we've got that out the way, description, link, description. Now we've got that out the way, let's get on with the tutorial. So we're going to need a couple of blueprints here. Let's see, where have we got all of our stuff? A couple of blueprints, a couple of textures. So we've got these textures, and I will provide those. Those are from opengameart.org. I'll provide a link to these. And what we're going to do is we're just going to delete these two materials out. Boink. Head into our level blueprint here and just delete a bit of trash that we don't need. And now we'll begin. So what we need first is we need a material collection. So we're going to right click materials and go to material parameter collection. And we'll call this hexagon coal. We're going to open this up, and what this is going to do is it's going to allow us to store multiple different parameters inside of a collection. We need to keep track of our player character, so we're going to use a vector parameter. So we're going to add an element, click the little drop down, and then we're going to give this an appropriate name. So we're going to say player location, and then we'll save that. Now we need to build a little bit of blueprint that will update this in runtime. Now we're going to build it inside the level blueprint here, but you can make this in any blueprint. As long as that blueprint is somewhere within your level, it will work. Right click, we're going to be using event tick. Now from the event tick, we want to update, no we don't, we want to set vector parameter value. And because we haven't got a material selected, it's going to give us the option of a collection. If we click this little drop down, you can see we've got all the different collections inside of our project. We can also just grab our collection from our content browser and drop that straight in. You can see there, it's updated it. What I'm going to do here, however, is I'm going to click this little drop down, and now we can see our player location. Ta-da! Now, what we need to do is we need to get our player pawn, and then we're going to get the actor location. And we're going to plug this directly into the parameter value, and it will create a conversion node for us. And now this is going to keep track of our player location at all times. Now we're going to right click and go to new material, hexagon_m. Obviously, if you want to use your own materials for this, go ahead. And if you don't follow my naming conventions, call it whatever you want. Drag in our little hexagon collection here, and you can see that we've got none. We need to go to the left and click a little drop down for parameter and select a player location, and that will then update. Now, to compare our player location to our material location, we're going to need a world position node. From our world position node, we're going to generate a sphere mask. Oopsie daisy. There we are. And we're going to plug player location into B, but we don't want to just do this directly because we don't need all of the data. We only need the R, G, and B. We don't need any alpha. So what we're going to do is we're going to comp mask this and only select R, G, and B. We don't want A. Plug this in. Hold S and left click for a scalar parameter, and this is going to be our radius value. Plug this into radius and give it a default value of 256, which is quite a nice size. It's what you saw at the beginning. Our hardness is going to determine the fall off of our mask. Now we want another scalar, so hold S and left click, call this fall off. Now the reason we're using scalars is because we can create a material instance, and then using a material instance we can quickly change these things in runtime or inside of our editor, so we can get multiple versions of this going using one singular material. Our fall off, the lower the number, the softer the edge. So we're going to go with 0.001. Now, if you want a harder edge, go for a higher number. The higher the number, the harder the edge. If we plug this straight into emissive color and press apply. Then it will compile our little shaders. There you go, get compiling. Now we'll grab this and drop it onto our floor. And once the shaders are compiled, our floor should go black. That's because we don't have any colors on this yet. But if we press play, you can see we have a white circle around our character. And if we run around, you can see it's simulating the kind of thing we had at the start. And if we jump, it takes it away. Cool. So it's updating our player location and it's telling our collection where the player is. So it's all working right now. We'll open this up, select all of our textures and drag them in. And now we're just going to rearrange these a little bit so we can get these in the right place. We're going to plug our albedo map into base color. Our normal map is going to go into the normal, as you'd expect. Our glossiness is going to go into roughness. And the final is the ambient occlusion map. We're using this as a mask for our glow. Now, white means on and black means off, so we need the exact opposite of this. You can either edit the image by just inverting it inside of your editing software of choice, or we can just use a 1-X node, which will flip it for us. From the 1-X, hold O and left click to get that, by the way. O, left click. There we are. Plug the 1-X into a multiply, which is M and left click. And then hold 3 and left click for a 3 vector, and this is going to be a color. Now we will assign a color. I'm going to pick green because I'm obsessed with green. We can right click this and we can convert this to a parameter if we want, and we can call this color. Oh, hello. How have we made a mask over there? Don't be cheeky. We can call this color. There we go. And now we can change that inside of a material instance, so during runtime as well. Now what we want to do is hold M and left click again for another multiply. Hold S and left click for a scalar. We're going to call this intensity. Oh my god, intensity. That's how you spell that word. Plug this into the B, and this is going to be how much our hexagons glow. We are going to give this a default value of about 15. Now, your glow is going to be determined by your hardware and what your project settings are. If you're on low graphical settings, you're not going to see glow as much. If you're on high graphical settings, it's probably going to work really nicely. But there we are. Now then, we no longer need the sphere mask to be plugged into our emissive. Instead, what we're going to do is hold L and left click for a lerp node. We're going to plug our sphere max into the alpha because the alpha is going to determine which bits we want to use and which bits we don't. Our multiply here is going to go into the B, and there's A, we're just going to leave it 0 because we just want that to be black. We don't want it to glow. We don't need anything in there, so we just leave it 0. If we plug this into the emissive, we'll then get our working glow. So we'll apply that. Wait for that to catch up. There we are. Wait for it to apply to our floor, and now you can see we've got this lovely texture. You can see we've got this green glow that's following the character, but our scale is way off, and that's just because of these maps. These textures are 4K for some bizarre reason, but there you go. Everybody seems to be obsessed with 4K textures. We'll open this back up, and just to fix the scaling, what we're going to do is hold a U and left click for a texture coordinate. This is going to be how our UVs are dealt with. Now you can just go in here and say U tiling and V tiling and change these, but we want to parameterize it so that we can change it whenever we need to. Hold M and left click for a multiply, put the texture coordinate in, S and left click for a scalar, call this scale. I'm going to give this a default value of 15 because that's a nice size. Plug that into the B, and then plug the multiply into all of our texture samples into the UV slot. This will ensure that all of our textures are using exactly the same tiling. Now, make sure if you're using a tiling texture that your scale parameter here is a whole number. Don't use decimals. If you use decimals, the tiling is going to break. You need to have the whole image repeated a specific amount of times. If I was to go with 15.1, I'd have a very obvious seam. It wouldn't be nice at all. So now you can see we've got much smaller hexagons, and if we press play, we're getting that really nice effect that we were getting earlier. Yay! Pretty cool, right? Now, one of the things that we've done is we've set this up so that it can be parameterized really easily. So what we can do is we can right-click the material, create a material instance, and now we'll apply that to the floor instead. You can see here it's updated. If we open this guy up, we can turn on all these little tick boxes, and now you can see here we've got this little example. Now this mask here is always going to be at 000 while play isn't going because it doesn't know where the player is, so it's just going to default it to 000 because right now player pawn doesn't exist. We can change the color to whatever we want. Let's go for a hot pink. We can change the intensity of how much this is going to glow. As you can see there, pretty glow. We can change how big the radius is. We can change how much hexagon is. Let's put it up to 30. Let's not have a non-whole number. We can even change the fall off. So you can see there the edge is getting really hard or really, really soft. Like so. Really hard, really soft. And you can change that all willy-nilly so you can have whatever it is that you want inside your project. Nice and easy. Obviously a smaller radius, you're going to get this really, really tiny ring. Not even visible there, look, pathetic. But there you have it. Pretty cool effect. Nice and tidy, nice and simple, nice and easy. So there you go, guys. I hope that you guys have found that useful. I hope this is something that some of you can use in a project, or you can adapt this in some way to be used elsewhere. Obviously, you don't have to do it exactly like this, but this is a really cool way of getting a reactive floor. But there you have it. As I say, the description, you'll have links for my Twitter, my Discord, my Twitch, and for the textures used in this tutorial. And as I say, if you could go and give me some support over on Twitch, it would be marvelous. The more I get over there and the more I get over here, the more I'm going to have time to spend making tutorials and streaming for you guys. Thank you very much for watching, and I'll see you guys next time. Bye-bye.